So yesterday, we talked about how, by the way, what form is this in? Standard form, right? But in order to get all the properties, we need to put it in what form? Vertex. Okay? So we need to take this and make it look like y equals a times x minus h all squared plus k. And then we can go ahead and state all of these things. Okay? When I complete the square on this, what's the first step I have to do in this one?
Take the 3 out.
Take the 3 out of these two. So when I divide the 3 out of those two terms, I'm left with x squared minus 4x. I don't take 3 out of this. That's over on the end. Why? Because I can only complete the square when I have an x squared, not a 3x squared. So now I have to figure out what do I have to add and then subtract to keep it balanced so that I can factor this into 2 binomials squared, or a binomial squared. How do I figure out what to add and subtract? Remember? Half squared. So plus 4 minus 4. Remember, that's still part of the taking out the 3. So this is the part that's factored. This I have to bounce out of here. But in order to bounce it out, I got to multiply by 3 because there's a times 3 in front. So when this disappears from here, what does it become here?
Negative 12.
Negative 12. Good. I keeps doing all these. So I'm left with 3. And what would this be when you factor it? X minus 2. Do you notice a quick way to factor these perfect square trinomials? It's always half the middle term. And then minus 12 plus 5 gives me negatives. So therefore, I am ready to state a whole bunch of stuff. What's the vertex of this one now that we've got it in vertex form? Sorry?
Positive 2.
Positive 2,
Negative 7.
negative 7. Domain, always. Now, the range. Without, we can do it without having to sketch it, but if you're not sure, sketch it. Okay? It's okay. But remember, it opens up, right? So it's going up to positive infinity. The question is, where does it start? It starts at the y vertex. So it goes from negative 7 to positive infinity. What is the equation for the axis of symmetry? X equals 2. Yeah. Max or min? Min, because it opens up. At where? At y equals y coordinate of the vertex. Y equals negative 7. Good. Okay. And then finally, I believe finally, yeah, the y-intercept. Well, you can find the y-intercept by plugging 0 into here and calculating it all. But it might be easier to find the y-intercept in standard form. Why? Because this becomes 0, this becomes 0, and you're left with +5. So it's actually easier to find the y-intercept in standard form than it is in vertex form. Right? Okay. So it takes us a few steps to complete the square, to put it in vertex form so we can find all of these properties. There is another way we can do it. Okay. That's actually much quicker. You don't have to put it in vertex form. You can use a formula and then some math. What I'm going to do, you guys, they actually used to do a lot of this in mathematics where you guys had to prove things. You had to prove formulas, okay? But not so much anymore. But I'm still going to do this. So you're not going to be responsible for this. You're going to be responsible for the formula at the end, okay? But I still want to show you where it comes from. Okay. We are going to take this and put it into vertex. So I don't have any numbers. It's just a general formula. Well, x minus h all squared means x minus h times x minus h. I just wrote out the x minus h squared. What's the next thing I'm going to do? I'm going to multiply these two together. So I'm going to get a times, well, 4 multiplications, x times x squared, x times minus h, negative xh, minus h times x, minus xh again, and minus h times minus h, plus h squared, yes. Plus h squared. So I multiplied it up. I can simplify inside the parentheses. What's minus xh minus xh? Minus 2x. Plus h squared. Plus k. Now I'm going to get rid of the parentheses by multiplying what I got here by a. So I'm going to get ax squared minus 2ahx plus ah squared, and then there's a plus k. So a lot of letters. Believe it or not, this is actually in vertex form. But it looks really weird. There's the x squared portion. There's the middle term. And there's the last term, c. So here, the value of a, well, it's just a. The value of b is this portion here because it's got the x in it, minus 2axh. And the value of c are these two things. I only want to focus on this one. So B is equal to negative 2 AXH. Or sorry, do I have that there? Do I have that? Oh yeah, no, sorry. B is equal to, that's where I make a mistake. We don't include the X. B is just equal to negative 2AH, pardon me. That should be just negative 2AH. Because we don't include the X as part of B. So I need to fix this too. How would I solve for H? How would I get H by itself? By both sides by negative 2A. Why did I do that? What's H again? In a quadratic function, what does H represent? The X vertex. So notice, I can find the X vertex by looking up in standard form, getting the value of B, and dividing by negative 2 times the value of A. That's much quicker than completing the square. So, to find the X coordinate, if it's in standard form, we use the formula X equals negative B over 2A. And once you've got the X, actually I'm going to call it XB for vertex. How do we find the Y coordinate? We plug X into the standard form and calculate Y. So to find the Y coordinate, we substitute whatever XB is, the X vertex, into the function. And calculate Y, which will be the Y vertex. Again, don't worry so much about the proof. I did want to show you where it comes from. This is what we need to focus on. So if we go back to that example, this one. I'm going to find the vertex without having to do this work. How do we find the X vertex? Well, sorry, first of all, I should state this. In this, what's the value of A? 3. What's the value of B? That's the one in front of the X. Negative 12. So to find the vertex, I use negative B over 2A. Or B over negative 2A. It means the same thing. So that means I get negative 12 over 2 times 3. What does that work out to? Negative 2?
2.
Positive 2. How do I find the Y vertex? I take that 2 and plug it back into here. What's 3 times 2 squared? 12 minus plus 5. What's that?
7.
Wait. What?
That's insane. Holy. The beauty of math.
Notice we get the vertex.
And if you've got the vertex, you can figure out all the other stuff.
Okay? So from this, we know that the vertex, and I'm not going to rewrite all these other properties. We know that the vertex, the x vertex is 2, the y vertex is -7,
And then we can go from there. Okay? Yeah.
I was just wondering, because if we go west and then down, right, so we basically get the vertex, so there's no point in doing all that.
All this?
The other one.
Well, no, you have to. Oh, you mean if you do this?
Yeah.
There's no point in doing this. You are correct. Yes. Either way works. Okay? However, I will ask you sometimes, put this into vertex form by completing the square. If you want to complete the square all the time, go right ahead. I mean, if you're comfortable with doing this, go for it. Okay? This is actually better when we start doing some word problems that you'll see, because some of the numbers are going to get very big. And so once the numbers get bigger, completing the square gets a little hard. Okay, but we'll cross that bridge when we get there. Okay, 6, 7. Apparently that's what you do. You just throw it out there randomly. Yeah, you do. Yeah, you do. You do. You just sit there, you talk. You talk about anything you want, and all of a sudden you just pass the rules.
Well, the